Good afternoon and good morning, good evening, depending on wherever you're joining us from the world. Welcome to the Building Your Industry 4.0 Roadmap webinar. My name is Mbali. I will be your host for this afternoon. I am the Business Development Executive for Winjit. We will start now just to give you a brief overview of who we are as Winjit and how do we then connect the dots with building this roadmap for you. Okay, if we can just start.
I have.
If you can start the presentation for me.
I have. It's on the who are we slide.
Okay, so Winjit was a, right. Okay, I can see it now. Winjit was actually established in 2004 in a city called Nasik in India. It was established by Abhijit Junagard and Ashwin Kandoy. It was firstly established as a software development company. It then grew. We still have product engineering as one of our core competencies. We've got over 500 customers worldwide. We've developed over 5,000 applications. We've had more than 50 million apps downloaded, and that's a massive and impressive status to have as an organization, right? We also have Internet of Things as one of our expertise. We've got companies or global presence in over 50 countries. One of our core competencies, again, is in artificial intelligence and machine learning. So what actually brings us together this afternoon is trying to help clients build the roadmap for Industry 4.0. So we've got a brief video that sort of takes us through the journey. What is it made of? What do we need to be prepared for it? And what exactly, which industries need to be part of this Industry 4.0 roadmap? So we'll just quickly go through that short video and then we'll take it from there.
Okay, so hopefully that gives you a bit of an idea of what Industry 4.0 is and how important it is to industry. You can see from the last slide, almost every industry is looking to get into it in some way. My name is Stu Chalmers. I'm the Vice President for Business Development in South Africa for Winjit. And I just want to introduce you to our product specialist, Priti Bakele. She's going to run you through a demonstration of one of the solutions we've built for Industry 4.0, which is our IoT Sense platform. And then I'll wrap up when Priti's done. So take it away, Priti.
Thank you, Stu. So when we talk about a journey towards Industry 4.0, so based on our interaction with several clients and the customers across the globe, so there are some of the common questions which we came across with respect to each and every customers. And all these questions somewhere fall in one of these three categories. So first, they either wanted to know like where and how they can start with this Industry 4.0 journey. And the second, what will be happening during this whole transition? Are there any prerequisites that they should be ready with, or are there any additional system integrations that they may need to do? Then the third thing is what impact or what benefit it will be creating for them. So this is where me and Stu will be walking you through the whole Industry 4.0 journey, and how this whole journey can be done within few easy steps with the help of the product IoT Sense by Vinjit. So yeah, definitely we will be jumping into that. But first of all, let me define you what this IoT Sense product is and what it does. So IoT Sense is a full stack IIoT platform, and it is scalable, and it could be deployed on the edge, or what we can say on premises, if you are very much concerned about the security and don't want your data directly to be uploaded to the cloud. So it could be deployed on the edge, as well as we give this platform to be deployed on the cloud as well. With this platform, it is based on the open API architecture, so which makes it very much flexible to connect with any of the systems which you might be having within your premises or for your particular industry. It also connects with the legacy as well as some of the new sensors which are coming in this Industry 4.0. So with this, what will happen? You will be able to visualize and modify the data which you are collecting from the different devices and the systems. And then on a top of that, you can generate some of the visual insights based on which you can have the informed business decisions. And how that whole journey will happen. So this presentation, whatever picture you are currently seeing, which very well explains it, where the IoT Sense actually sits and how it helps you transition to that Industry 4.0. So when we are talking about this whole Industry 4.0, so it is all about the data. So the data is the new oil, we can say. So this is where this first data source comes in picture, wherein IoT Sense will be collecting data from the real-time sensors, devices, machines, PLCs, and not only the data from these devices and the sensors and machines, but it will also collect data from some of the systems like MES, ERP, MRP, or the SCM systems, whichever you will be having. And don't worry if you don't have any of these systems. IoT Sense platform is smart enough and capable enough even to incorporate some of the additional details which you may need to have that informed business decisions. Once we collect all this data from these different data sources, so what value it will create? It will crunch that data, it will perform some of the advanced algorithms, on a top of which it will give you representation like digital twin, then the data stream visualization in real time. You can have the critical parameter monitoring in a real time to take the decision then and there only, to avoid further delays or to avoid further defects within your production line. So all this is getting turned into the informed business decisions. So you will be able to forecast your production. You can do the order scheduling. You can even perform some of the advanced business frameworks like Kaizen, Poka-Yoke, TQM, and Six Sigma. So this is where IoT Sense stands. So next. And of course, when we are talking about this whole journey, what impact it is going to have on your business, and it is going to be a positive impact. So of course, with all this data collection and giving you the visibility, you will be having provision to maintain your production efficiency. You will create a customer focused impact, and with this, ultimately, it is going to drive the profitability. You will have a better quality control on whatever production is happening within your industry, and you will be able to monitor your work in progress and what all things happening in a real time on your factory floor. And even there are some of the challenges with respect to the machine downtime, unwanted machine downtime. So that will also be avoided with the help of predictive maintenance. Yeah, next. So to give you better visibility of it, how we are solving customer problems with the help of IoT Sense. So I would like to present one of the actual use case with which we have solved one of our manufacturing client requirement. So there were certain issues this particular client was facing. There were a lot of unwanted machine downtime, and due to which they were losing a lot of profitability. Also, there were due to this unwanted machine downtime and inefficiency of the machines, so whatever products were getting developed, those were also having a low quality, and they wanted to increase their order or the production efficiency, ultimately leading to the cost optimization. So this is where we given them a journey with IoT Sense, where we provided a solution where we've given them the unification of all this data. So that client was already coming up with their MES and ERP system, and also had some of the PLCs or energy meters or the sensors, what we can say, implemented. But the problem was there was no common connection between these data, no unification on based of which they can take some informed decisions. So this is where we help to unify all this data via Industry 4.0. We help them to identify the inefficiencies and then baseline data for achieving the other efficiencies, and what business benefit ultimately they had. So they were able to achieve the 60% increase in their machine utilization by, of course, some of the techniques like preventive maintenance and real-time monitoring. They also increased machine efficiency by 20%, and then daily production count were almost increased by 10k pieces. Daily production, as I can say, it is the good count, or what we can say, the accepted count of the pieces which has got increased. So this is what now I will be showing you now how we help this particular customer transition to this particular industry 4.0 within IoT Sense. But how we did it, we followed 4 simple steps. So if you are also thinking of transitioning your industry to this industry 4.0, all you need to follow is the 4 steps with IoT Sense. So first, what we did, we onboarded all the devices and the PLCs or the sensors to our IoT Sense platform. And as I said, those people were also having some of the static data coming from the ERP and MES systems, like what are the workers working on that particular factory floor, what are the different operations. So that data also we onboarded within IoT Sense platform. So that was the first step. In the second step, what we did, we collected all this data, and obviously that data was not ready for the final utilization or the what we can say generating the actual insights. So we needed to process that data, and we processed it within the IoT Sense platform. And then for the next step, we given them the ability to generate the notifications and the alerts for their factory managers and the operators to take the decision then and there itself. And the final and the very much important step of all this data collection and alert mechanism was to have the visual insights or the report. And those are not the simple reports. With this data coming in picture, we perform the advanced AI reports. So this is what I'm now will be walking you through with the actual IoT Sense platform. So let me directly jump to the IoT Sense platform and how this all 4 steps happen within it. Okay, so this is our IoT Sense platform. So as I mentioned, for the first step, we onboarded all the sensors, all the machines. So as you can see under the resource management, we have different sites. So that particular client were having 2 different sites, Asheville and Livonia. Within that Asheville plant, he had 2 different production line, Asheville line 1 and Asheville line 2. So those are visible here. So under that particular Asheville line 1, we will be considering this particular production line itself. So it has 4 different machines working under it, but it is each and every machine has a different so different sensors and energy meters and PLCs associated with it. So this is 1200T PLC, which was associated with 1200T machine, and it has once we onboarded this with that particular protocol, it started giving this kind of data. So it is coming in real time here within this. And after that, I also said like we onboarded some of the non-sensory data, like who are the operators working on that factory floor. So these are the operator data, and similarly we have some data related to operations, and then some data related to shift. And then, as I said, we perform some of the advanced analytics, or what we can say the data modifications. And how we modified this data with the very powerful feature within IoT Sense, the data flow management. So here we can see some of the things data flow. So this one is actually the things data flow, wherein we were capturing one of the data from the imagery machine, and we were just getting converted into the actual output. Means we wanted to see if that particular device is having any of the defects or not. So this is where different nodes comes in picture. You can perform some of the complex algorithms like distance measurement or the pressure, speed. So that kind of advanced things that we perform, and we converted that particular data within a required format, which can be ultimately utilized for the final visualization of the data. And then at the third step, as I said, we were able to give the required alerts and notification to the factory workers or the managers. So here we had set some of the alerts like low OEE trigger. Let's say if any of the machine is falling particular OEE below, let's say 40. If I want my OEE to be maintained greater than 40 itself, and if anything wrong happens, and if that OEE falls below 40, so what we have given? We have given an email, okay? So wherein you can write your operator or manager's email, and they will be notified in real time when this OE is going to fall below 40. So this is the third and the important step. Now let me show you the actual interesting stuff, that is the analytics. So once I click on this analytics platform, so within analytics, what will be happening? Whatever data we have collected so far, all this data is now getting converted into the graphical representation. And this is what it looks like. So as you can see, within simple representation, I can see what all production is happening on each and every machine. If I want to see what is happening on 600 TA machine, so average it is giving production like 94.77K. Okay, and then there is another interesting widget. Considering the current situation of the COVID, we needed to maintain certain social distancing among people. So these are the different workers. Okay, and if any of this worker will be crossing some proximity restrictions, then what will happen? That notification will be given to that particular plant manager. So you can see some of the distancing alerts. So like Annette Caskey is in close proximity with Augustine Seawood. With this, what will happen? Manager can instruct that particular Annette Caskey. So if I just click on that Annette Caskey and see further who is in the close proximity of that Annette Caskey. So Augustine Seawood is there. So this will be giving you data in real time. And this can also be utilized for some of the machines which are hazardous or which may need to be handled in a careful manner, and no person should be roaming around that particular machine. So for that as well, with enablement of the Bluetooth low energy devices, you can have or you can set that particular distancing alerts to them. Then let me show you the actual what we can say the original equipment efficiency or the OEE parameters for all the machines and the devices, and even for the workers, how they are operating. So within few clicks, we have created this customized widgets. So wherein you can see the shift OEE, then what all production is happening on each and every machine, and how it is getting varied on a particular time interval. And then even you can see how each and every operator is performing. So as I can see with this operator performance PLC graph, the Augustine Seawood is having very much high efficiency. He has he almost have the large number of pieces which he had produced successfully. And somewhere we need to take action for the Angelita Matson, because that particular person may not be giving the proper what we can say, not performing efficiently because the production count is very much less as compared to the other operators here. And even you can decide or you can visualize the OE for any of the operations. So by this representation, as I can observe, the feeding and shearing operation available here has the maximum OEE. That is, this operation is getting performed in a very well manner. But when we observe this stretch drawing operation, it has a lower OEE as compared to others. So we can have the I mean analysis like we need to optimize this process of stretch drawing to increase the OEE. And similarly, we can see the particular machine OEE as well. So this is not it. So there is something more to it. Let's say you are procuring some of the materials from some of your vendors, and you want to see whether that particular shipment is reached to your required location or not. And how can you do that? With the help of smart OBD devices. This is what the data will be communicated to this IoT Sense platform. You can onboard this device. You can see whatever that particular vehicle which is bringing your shipment or the material required for the production of the pieces. So you can see what is the current vehicle load or the engine load, how much is the RPM. But another interesting thing is even you can trace the actual location of that particular shipment where it has reached, and the part which you are able to see in this blue. So that is nothing but the geofence. So how is it helping with the geofence? Let's say I want that particular shipment to follow the path. Let's say if I just zoom in a little bit here, you can see that road name is something N Intersect 35 Fortage Road. I want that vehicle to be coming to my location only with this road, and I don't want this particular vehicle to follow this SHI frontage road. Okay, so what I'll do, I'll just add the geofence there. And as I can see, if I just trace the past path, what that particular vehicle has followed, it has followed the right path. Okay, and even you will get the real-time notification as on when that vehicle going to pass with particular geofence, like an intersect road, entered highway. Okay, so this is how you can get the real-time notifications for your shipments as well. Now let me talk you about a little bit related to the predictive maintenance and avoiding unwanted machine downtimes and how we achieve that. So we achieve it by continuously monitoring your machines for any of the abnormal behavior. So as you can see here, so this anomaly alert. So it is saying something like system has detected an anomaly for SM150 vibration sensor. So it is saying whatever vibration sensor we had connected for that SM150 machine, it is showing some abnormalities there. Okay, so if with that, what will happen? You can see the actual anomaly happened there, and what all wrong things are going with that. Okay, so this is the anomaly, and if I just click on that root cause analysis report, you will be able to see what may have caused this machine to behave in an abnormal manner. Like this is N50 SM150 vibration sensor. This is causing it to vary, and there is a voltage change actually within that machine, which has got this abnormality. And as you can see, the vibration sensor was working very much fine, but this red dot, this is the abnormality within data, which gives a real-time notification to you, and plant manager can take the respective action for this causing parameter, which can further prevent our machine from failing. Then we have the digital twin visualization of the machine, which you can see here. So this is the particular production line, and these four are the machines on that particular production line. And this is a very powerful feature within this IoT Sense, wherein you get the actual data visualization. So if I wanted to monitor this Asheville line 1 1200T machine, I just clicked on this view details, and I'm getting the detailed overview on what all things are happening. Let's say if I want to see what is currently happening, what is the average count of the let's say the production, and the accepted count and the rejected count for the last 6 months. I can get that visualization with few clicks. So this is again a very powerful thing within IoT Sense. Even you can download this data, even you can export this data within whatever format you want. So, so this is what the visibility we have given to our client to solve that, solve its particular issues with respect to the production efficiencies. Yes, too, you can take over.
Okay, thanks, Priti. So yeah, I'm just going to wrap up here as far as this is concerned. So, so I know we did a little video on 4IR and what the definition is, but I also pulled this out from Wikipedia, and I think we've covered some of it. So, fourth industrial revolution is the ongoing automation of traditional manufacturing and industrial practices. So as Priti said, that involves legacy equipment, making things that weren't smart, using large-scale machine-to-machine communication, and the Internet of Things for increased automation, improved communication, and self-monitoring, and production of smart machines that can analyze and diagnose issues without the need for human intervention. So, really, automation is the key. Getting machines to speak to each other, and what I'm a big fan of is automating existing equipment, existing machines, listening to what they have to say. There's ways of adding small sensors or pulling existing information from equipment that you already have on site or in your fleet. And I think we call this the 4IR roadmap. And I think it's good to understand that it's not a one hit to try and convert your business from non-digital to digital. It is a journey, it is a process, and you can undertake it over a period of time as budget allows, as ROI from the first phase kicks in, and then you start to be able to fund the second phase or the next phase. So that's kind of where we're coming from. We the way I look at it is IoT is probably quite a key part of that 4IR journey, and it can be, and I'll run through in the next slide, it doesn't have to just be manufacturing. It can be in an office environment, it can be in all kinds of different environments, but IoT plays a big part. I think machine vision is a big part of it, so using computers as a sensor, or using cameras as a sensor. So there's a multitude of data inputs that a camera can give you that would require several different sensors to do the same thing. So things like movement. Priti was talking about people being in close proximity. There's a whole bunch of things. Temperature. Things that you can use a camera for. So it can do all of the different things at the same time, as opposed to a sensor doing one of each of those things, proximity and perhaps machine vibration and that kind of thing, which a camera can do. And then the key, once we've got the data from our IoT Sense sensors and our machine vision, is machine learning. And this is how, so for me, this is a progression across the journey. And machine vision machine learning is the tool that we use to interpret the data. There's going to be so much data that comes out of this process. We really need to have a tool that helps us to do that. It helps us with predictive maintenance, forecasting, and we can improve the models with more data that we get. So the more data we have, the better the models become. And one of the key things I think we need to understand is the approach to change management. So 4IR, any kind of, from the first industrial revolution, to the fourth one where we are now, people have always had a concern that their jobs would be at risk. And there is a certain element of truth to that, but we need to understand how do we take people from a role they're in now that's completely reliant on a person, where now then we can automate some or all of that role. What are we going to do about the people, and how do we manage that change? I think it's a very important step that we need to understand as well. So I call this slide 4IR dreaming, and it's kind of what do we do with in the fourth industrial revolution. I talked about different industries. Obviously, manufacturing, is a key part of it. Using it for things like asset tracking and logistics planning, and Priti went through that as well. Fun stuff like home automation you can do as well. Facilities management is a key, I think, is a huge untapped market for for new technology and digitization, to manage costs, to manage buildings, to turn air cons on and off when they're not needed, lights, manage security. There's a whole range of things that I think is quite an untapped market in the facilities management place. And then, digital twins, which Priti talked about in the platform. It's also great for planning. You can utilize them to trial, to test run production runs. I saw a great example of using a digital twin to figure out how to get an old piece of equipment out of a factory that they basically built around this old piece of equipment, and they needed to replace it. And it was this huge behemoth of a thing, and they didn't understand how they were going to get it out. They built a digital twin and then planned an exit strategy, and then did it over 100 times before they physically did it. So you can use it for things like that, or physically planning production. I want to put these different machines in line. Are they going to work effectively together? So that's the beauty of it. There's less trial and error. There's more, let's do a trial and error as a digital tool, and then take it over from there. So that's us. I just wanted to give you a little bit of an idea on our process there. I don't know if there are any questions that anybody has, but happy to take any questions, or if you want to raise that with us. Okay, no worries, guys.
We don't have any questions at the moment.
No questions. Thanks, Stuart.
Okay. All right, guys. Thanks very much for your time, everybody. Then, and appreciate your attendance. And if you want to know a little bit more, or you want a more in-depth demo, or you want to know more about our machine learning applications, that sort of thing, please get in touch. You know who we are. Thanks a lot, everybody.